Okay, so last lesson we looked at sort of defining all these terms: speed, velocity, displacement, time, acceleration. Okay, and we went through, so just as a quick sort of reminder, we have displacement, and we need to remember why that's different to distance. Remember this diagram I showed you? Okay, you can have travelled a distance but only be a certain displacement. Okay, a really good example of that, by the way, is if you were to go for a bike ride or a run and you came back to the same place you started, then your overall displacement at the end is 0, even though you have travelled a distance. Velocity, okay, it's different to speed. Velocity has a direction, and we can work out our velocity using the change in displacement over time. We have final velocity and initial velocity. These are given as u and v. Acceleration, rate of change of velocity. Okay, remember where that comes from. We can think about it from a calculus point of view or from a kind of more straightforward change of velocity over change in time point of view. Average velocity, this is the last thing we looked at. It only works, this formula here only works if acceleration is constant and I'm travelling in a straight line. So let's see where we've got to then. So we have a few formula to work with. We have velocity is change in displacement over change in time. We have acceleration is change in velocity over time. And we have average velocity is essentially the mean value of my two velocities. Okay, so 1 plus the other divided by 2. Okay, so SUVATs. You may have heard of SUVATs before, you may well have done them before. I know that my physics class are quite sort of used to these already, but there's no reason not to practice them and make sure you're happy. Essentially, SUVATs are 5 equations of motion which each have a different variable missing. What I mean by this is one will not have time, one will not have displacement, one will not have acceleration, etc., etc. And it means we need all 5 because we have 5 variables. These variables, just to remind you, are S, U, V, A, and T. So remember that S is displacement, U, initial velocity, V is final velocity, A is acceleration, and T is time. Now units, make sure we're happy with these as well. The unit for displacement is m, meters. The 2 velocities, meters per second, or ms to the minus 1. Acceleration, m slash s squared, or ms to the minus 2. And finally time, s. Okie dokes. Now, what we're going to do next is we're going to derive these 5 equations, and you must learn how to derive these, okay? You must practice them, okay? They have come up in tests, and it's also a very, very good skill to learn. So our first, I'll just leave those there. My first SUVAT, now they don't necessarily have an order, but it's good to learn them as 1, 2, 3, 4, and 5, because you can refer back to them. And when you write out the list of them, you know, it's good to keep them in the same order. So the first one, it's very straightforward. We take our acceleration formula, which is A equals V minus U over T, and essentially all we do is we just rearrange it. Now, this shouldn't be too taxing, but I just want it to be V equals. Okay, you can keep it like this if you want, but it's usually written as V equals U plus AT. And actually, it makes quite a lot of sense this way, because our final velocity is our initial velocity plus how much velocity I've gained. Okay, AT, if you think about it, is also velocity. Okay, so acceleration times time, if you think about it as ms to the minus 2 times s, is going to give us ms to the minus 1. Okay, so at is actually a velocity. So that's the first one. Okay, this one here. And what I'll do is I will just sort of give it a little cloud to sit in. There we go. Not pretty. Right, number 2. So SUVAT number 2, what we do is we take we take v equals s over t, and we rearrange this to start with. So we go, well, that's s equals vt, as in my displacement equals my velocity times time. That's a GCSE concept. And then what we do is we take our average velocity. If you remember this, the average is u plus v over 2. And essentially what we do is we put this average velocity in here. Okay, and so once you've done that, you end up with s equals u plus v over 2, all multiplied by t. And that is our second SUVAT. Now, as we go through, I forgot to do it on the first one, sorry. I'm just going to put in brackets what's missing here. Okay, so we've got v, u, a, and t. So this one has no s. Okay, no displacement in this one. Whereas the second one has no acceleration. And that's important because when you look to use or decide which SUVAT you're going to use, you need to know what is there and what isn't there. Okay, number 3, this one you'll use an awful lot. Now what we're going to do here is we are going to start with essentially a rearranged version of our first SUVAT. Okay, so what we're going to do is we're going to rearrange the first SUVAT for t. So if I start with v equals u plus at, take away the u and divide by a, I end up with t equals v minus u over a, and that equals our t. Okay, hopefully you're happy with how you can get there. The next thing we're going to do is we're going to go back to this here, so our s equals vt, and we're going to use our average velocity again. So we're going to say, right, well, s must equal this v, u plus v over 2, and we're going to times that by this t here, okay, from the first equation. So we end up with v minus u over a. Now, there is a simple way of doing this, which is that I can just put that t into here, but you'd have to find the second SUVAT to find the third. So it's nice to be able to start from fresh each time. Now, if this looks intimidating, okay, let's break it down. The numerator here is u plus v times v minus u. So this is a difference of 2 squares. And so with this, we end up with v squared minus u squared. At the bottom, the denominator, we end up with 2 times a. And then all we do is we just tidy it up a bit. We times by the 2a on this side. That gives us 2as equals v squared minus u squared, which I can then write as v squared equals u squared plus 2as. And that is our third SUVAT. Okay, so once you've got the second one, the third one's quite easy to do. And this one, if you notice, what's missing? Well, there's no t, so time is not relevant to this one. Okay, so if you're not given time in a question, you might want to use that third SUVAT. Okay, moving on. Number 4, just 2 more to go. Number 4, what we do is we start with our second SUVAT, which is u plus v over 2 times t. And what we do is essentially we're going to rearrange my first equation again, and we're going to pop it into here. So if we think about v equals u plus at, this v and this v are the same. So I'm going to substitute in all of this in place of that v. So I'm going to have s equals u plus this here, which is u plus at. That's all over 2, and it's timed by t. U plus u is 2u plus at over 2 times t. It's going to all fall out. The 2 is going to cancel here. That's going to give me ut plus a half at times t squared. This is perhaps one of the more difficult ones to derive, but trust me, practice it a couple of times and it will be a piece of cake. Okay, in this case, we do not have v, and that should make sense because we cancelled it here. The very last one then is actually very, very similar to the fourth. So we're going to start in a very similar place. So we start with s equals u plus v over 2 times t. Now instead of using v equals u plus at, I'm going to use u equals v minus at. Hopefully you can see where that's come from. And then all I do, substitute in place of u here. So this gives me v plus v minus at all over 2 multiplied by t. I'm going to go across to the right here. So that then gives me s equals 2v minus at over 2 times by t. I'm just going to break this one down a little bit because I didn't do a very good job of it last time. So this one inside the bracket, I'm going to times it by t first. So we have 2vt minus at squared over 2. Now because we've got a single term in our denominator, we can split this up. So that becomes just vt and minus a half at squared. Okay, again this one gets its own little cloud, and we notice that this one has no, sorry, that should say u. I went for a u and it with a v. There you go. Okay, those are our 5 SUVATs. Okay, so what I'm just going to do now is, and feel free to pause this video and go back, I'm just going to move that to there. So I'm just going to list them out here. So we start with v equals u plus at. By the way, if you're freaking out at all at this point, don't. That's good advice, isn't it? But you will be given these in your exam. I can almost hear a few of you breathing a sigh of relief at that news. I'm just going to write that one in third place, not second. So you get given these in your formula book, which is fantastic. Just great news. So actually the challenge here isn't learning them, it's learning how to use them, and it's learning how to derive them. That's the third one. The last 2 are easy because they're very, very similar. And what I suggest you do before you do any work on SUVATs is write the 5 down. Okay? And if you want, also write down what is missing from each one. Now, it's always pained me that it doesn't spell something really nice down this side. SUVAT Satvu doesn't really, it's not the most kind of memorable word, is it? Anyway, what I'm going to do is I'm going to give you a couple of examples of how to use these and the best way of sort of modelling these. So if I just leave that there, what I'm going to do, and here's some fantastic advice, probably, is every time you do a SUVAT question, write down S, U, V, A, and T. Every single time you do a question. Now this helps you because it helps you work out what you've got, what you need, and then which one of these to use. Yuki digs. So here's our question. So we're going to have a car. It's going to accelerate from rest. You can think about what that means. With acceleration, so our A is going to equal 2.5 ms to the minus 2 Okay, and it's going to accelerate 4, 5, let's make it a bit longer, come on, 10 seconds, whoa, exciting. I want you to find V. Now if you want, feel free to pause the video and have a go yourself, but I'm going to go through the solution now. So I'm going to fill in this first. Now what's really important here is that you notice this word here, rest. Rest means 0, okay, in mechanics. Okay, if something's at rest, it's not moving, so it's 0. Its velocity is 0. So what do I know? Well, I do not know S. Do I know U? Yes, I do. It's 0. V, do I know that? No. In fact, that's what I'm trying to find. Okay, so I often put a little kind of star next to that because I'm trying to find that. A is 2.5 and T is 10. Okay, and what I'm actually going to do here is, because I know that I can get rid of one of these because I don't need it, I'm going to get rid of this top one. I don't need S. Okay, and that also helps me decide which SUVAT to use. Don't need S. Which one doesn't have S? Oh, this one. So I'm going to use this first SUVAT. Have a little think about that. You've got these 4, or at least you want to find V, so we need this first equation. So write it down. V equals U plus AT. Simple stuff. Sub everything in that you've got. U is 0. A is 2.5. T is 10. So our velocity, 2.5 times 10. No calculator required. Thank you very much. 25 meters per second. Okay, now this kind of question might have a follow-up at this point. It might then say, also find how far it travels during that point. And at this point, all you do, redraw your SUVAT and work out which one you need. Okie dokes. Right, another question. Again, what I'm going to do before I even start this question is I'm going to write SUVAT. You might think this is a real pain to do, but actually A, it's not, and B, it means you get the answer right. So actually it will save you time in the long run. You're welcome. So next one, another car accelerating. God, boring. Car accelerates from 3 meters per second to 26 meters per second in 12 seconds. Okay, question is, how far does it travel? Now it might be worded better in the actual question. It might say how far does it travel whilst it accelerates, but I'm going to leave it there, you know what I mean. So it goes from 3 to 26 in 12 seconds. How far does it travel? Right, well, let's just have a little look here and fill these in. So we want to find S. Do we know what U is? Yes, we do. It's 3. V is 26. A, don't know that. I'm just going to write A. And T is 12. So I've got a feeling I'm going to be crossing out A here, but let's just check. We want to find how far it travels. Do I need A? No. So A is going to fall on its sword. See you later, we don't need you. So let's just scroll up here and see which SUVAT is going to be appropriate. Well, look, the second one here doesn't have A in it, so we're going to choose that. So I want S equals U plus V over 2 times T. Okie dokes, right. So again, this is easy. We don't need to rearrange it too much. We can just put in our values and see what happens. So U plus V, that's 3 plus 26 divided by 2 multiplied by 12. Now, I'm actually going to use a calculator here. So 3 plus 26 is 29 divided by 2 times 12. Okay, for those who did that in your head, well done, you're very impressive. It's travelled 174 meters. Okay, so you're going to have a go at some questions. Each one you do, make sure you write down your SUVAT, okay, and write down which bits you have. refer back to your 5 SUVATs, and also make sure you can derive them all. Okay, it is really important you can do all of the derivations that are shown here. Okay, so that's it. You can crack on, and I'll shut up. All right, bye.